Hello everyone, today we are solving Leetcode 47 problem, which is permutations 2. So this problem is very similar, or you can say the continuation of the problem permutation 1. So let us understand what both the problems are saying. See, permutation 1 problem was like you are given an array with distinct elements and you have to return all the permutations of the array which can be formed like 1 2 3, like 1 2 3 3 2 1 2 1 3 and so on, like uh, so this was permutation 1. But the slight change in this problem is that now you don't have distinct elements, now you have repeated elements also. Now you have repeated elements and you have to give all the unique permutations. Like for 112, the example given in the problem, for 112 you have to return only 3 combinations: 112, 121 and 211. But if you will solve it by this approach, you will get how many combinations? You will get 3 factorial. You will get 6 combinations, 6 answers you will get. But we have to return only 3 answers. So let us find how we can solve this. First, we'll understand how to solve this question, and then we'll move on to solve this question. This is very easy if you know the concept of solving the distinct problem. Okay, so let's start. Let's say we have 1 2 and 3. We have an array which contains element 1 2 and 3. Now what should the approach of doing the problem? First we have to find all the permutation. Whenever all the combinations, all permutations, these words comes in a problem, the only approach we go for is recursion or backtracking. So in this problem also we are going for backtracking. But how to start thinking about backtracking? See, forget about backtracking. Let's start making our own permutation. What you will do to make next permutation, like 1 2 3, what you will do, you will rearrange. You will think, okay, I'll put 3 here and 1 here, I'll get one more permutation, 3 2 1. Okay, then I'll put 2 here and 1 here, then I'll get again 2 1 3, one more permutation. Now you will say, okay, in this move these two also, so you will get 3 1 2 okay, this is also fine. Now you will say move these two also, so 2 3 1. So what are we doing? We are swapping. You are swapping this. Now here you are swapping this, but we are swapping unorganized, unordered, in an unordered fashion. So let's make it a like in a ordered manner, and then we can think about the code. Okay, so let's say 1 2 3, this is the array. Now if I have to swap one, how many options I have? I can swap it with 2, I can swap it with 3. One more option I have, that I can swap it with 1 also. That will result in only 1 to 3 only. That will result in the array itself. So if I swap it with 3, it will give 3 2 1. And if I swap it with 2, it will get 2 1 3. So we got 3 combinations. Now what? Now I will take the second element. See what you were doing here. You were taking second element. And then swapping it with the next. Similarly, now take second element. Now this also have 2 options. Swap it with 3 or swap it with itself. So if you will swap it with 3, you will get 2 3 1, and if you will swap it with itself, you will get 2 1 3. Similarly here also, take this element, swap it with itself 2 or the next element 1. So the combination will be 3 2 1 and 3 1 2. Same case here also, take this element, swap it with itself or with 3, so you will get 1 2 3 and 1 3 2. So 1 2 3 4 5 and 6 answers you are getting. Since all are distinct element, these answers are also distinct. 2 3 1 2 1 3 3 2 1 3 1 2 1 2 3 1. All answers are different. Let us try with 1 1 2. Okay, see, looking at this tree, can you think how our code will look like? Like how many pointers or how many vectors we require? See, one vector will require answer for storing these answer. What will be the base condition? Now, why is we stopped here? Why we stopped here? Why we are not considering one and swapping it? So if you will consider one, let's say you are considering one, you have only one option to swap it with self. You don't have any other option. So that's why we are stopping it here. So I got a point or a hint that I have to take an pointer which will iterate through is first we were at one, so we were having three options. Then again we went to the second element and we had two options, and then when we went to the third element we only had one option, swap it with self, which will, if you want to do that, we will do that. So base condition will, let's say you are thinking that I will do that, and there is one option swapping it with self, so you will get only this answer. So now the pointer is out of your range. So what is the base condition? Base condition is if the pointer you are taking is equals to arr dot size. This is arr dot size. This is arr dot size minus 1. This is minus 2. This is minus 3. Similarly, so this is the base condition. Now, do we require something else? Yes, we require a for loop. For loop for choices. One, we are having three choices. Then we are having two choices. Those choices depends on the pointer k, where you are putting the pointer k. That decides how many choices you are. When we will code, we'll get more idea, but first look at how the duplicate will affect the answer. Okay, so we are having pointer at 1. Okay, so swap it is with self 1 1 2, again swap it with this 1 1 2 and 2 1 1. Pointer is here, pointer is here. We are having two options, 1 1 2 or 1 2 1. Here also 1 1 2 or 1 2 1. Okay, here also, so pointer is at here 2 1 1 or again 2 1 1. So you are seeing that we are having so many repeated answers, 2 1 1 2 1 1, 1 2 1 1 2 1, 1 1 2 1 1 2. Those unique answers are only three. This one, and this one. We are having only three unique answers. So how can we generate these unique answers? See, there are so many methods you can implement logic to filter out the unique answer. But the best thing which I like, which you can use, which Leetcode also passed all the test cases, is use map. Use a map. Yes, it will increase space complexity order of n, but it will it will be very easy, and Leetcode is helping in passing all the test cases. So you can use hash map or set. You can use hash map or set to filter out these. Like if you use set, it will automatically filter out the unique element. So that is the thing you can do. And why it is working? Because in recursion, like in permutation combination, in like permutation type questions, you cannot have very big input like n equals to 24. No, you will not be having like this much of big input. If you will see in the constraint, you are having only length of the array is only between 1 to 8. Why? Because for 8, like let's say you are having an array of 8 elements and all are unique. So how many combination you will get? 8 factorial. 8 factorial, if I calculate what is 8 factorial, so 8 factorial is 40,320. This many combinations you will get. That's why looking at the constraint, since we are having only 8, maximum 8 length of array, we can use a set, because it will again use order of 8 space. This is not much space. So that is why I am suggesting to use set for filtering out the unique elements. So let's start writing the code. You can the code is similar for both the questions. The only difference is that we will use the set for the second question. So what is the base case? Base case will be again the pointer we are using is as will equal to the size. Then what we will do, we will store it answer in a set S. You can use like you can use the same array nums or array which are provided in the question, or you can pass like another array. This is up to you. Okay, and then return. Now we will, for choices, we'll have to make a loop for int I equals to k. See, 1 2 3. From where we have to start? Like if k is here, we have to start from this, swap it with yourself and with this. So I less than size, not equal to, less than size and I plus plus. Swap it with itself or swap it with ARR of k comma ARR of I, ARR or nums, and then again let's say the function name is solve, and again solve, pass k plus 1, because next time this k will be here, k plus 1, and all the other parameters like set and nums and whatever. And for backtracking logic, swap back. Yeah, this is the backtracking code. I hope you got it. Yeah. First it will try this option and backtrack, and then it will try this option, and then it will again, after trying this option, it will again go backtrack and it will try this option and this option. Okay, so let's code it. So the problem which I am solving is of unique containing duplicates. Okay, you can solve any. So what we will require, first we'll require a set. So set of what? Vector. We are storing nums in it. We are storing the combinations, we are storing a array in that set. So okay, vector, let's call it as, and but we have to return a vector in the answer. Okay, you can see we have to return a vector of vectors, like array of vectors. So array of array, you can say. So we will take the inputs in the set, it will contains only the unique element, then we will put it into the vector and we will return it. For example, let's make an answer vector. So vector int answer, and what we will do, s dot begin comma s dot end. But first we will solve. We'll put the answer in the s and then we will do it. So let's call our recursive function solve. It will take k, our pointer, which will initially be at the 0. It will take set s and it will take nums. We have to give nums. Nums is let me see if the question is similar to the Leetcode. Consisting n integers. Okay, n is a size, n is nothing but size. Okay, so we will give array. Okay, now let's write the solve function. It will not return anything, it will just modify. So it will take int k and set of vector and it pass it by reference, because we are modifying the original set, we don't want copy. Okay, and again a vector int answer, not answer, array, ARR. Okay, now let's write the base case. So if k is equals to ARR dot size, you can use n also because n is the size of the array only. So what you will do, s dot insert what, nums array, and return. Okay, return. Now Now for int I equals to similar code which I have said taught you. I equal to ki less than arr dot size I plus plus swap arr of I comma arr of k, again k plus 1, and set s array as it is, and backtrack, swap back arr of k comma arr of I. This is the code. Okay, let's return the what answer. So return answer. Okay, let's run it. Compilation error, something is missing. What is the problem? In file included argument 2 is invalid. It is saying argument 2 is invalid because I haven't put one more closing bracket. Okay, yes, all the test cases have been passed. Let's submit the code. Yeah, all the test cases has been passed. You can do it without using hash map, but since in all the this type of permutation question the array size is very limited, you can use it set or map because it will not take much space. Okay, thank you.